Question number 5. A constant horizontal spring or spring constant K and negligible mass M is compressed to a distance Y. Okay, you are compressing it like this. And from its equilibrium length, an object of mass M that moves on a frictionless surface. So this object has no friction. Okay, is placed at the end of the spring. The spring is released. The moment the spring is released, and returns to its equilibrium length. So what will happen? The object will start flying over here. So start moving over here. What is the speed of the object just after it leaves the spring? So from here to here it moves and then it starts moving. Now why should the object move? Because there is an elastic energy stored in the spring, compressed spring. What is the elastic potential energy in the spring? The elastic energy here is nothing but half k x square. Now since no energy is lost, the whole energy is given to the object, which means the energy of the object when it leaves the spring is half mv square. Now I can equate these two. I can now write half k. So it's just compressed by y. So what I will do is I'll write it as half k y square is equal to half mv square. Okay, what is being asked? The question is that what is the speed of the object? V is the speed of the object. So therefore half and half goes away here. V square is equal to k by m into y square, or let me take up a little bit up, right? Okay, or V should be equal to square root of k by m into y, which is the right answer. Answer is C.